In this lecture, we will be seeing another example of how to find the regular expression for a given NFA. So if we see here, we have an NFA given, and our task is to design the regular expression for the given NFA. So in order to do this, what we have to do is we have to write the equations for each of the states of this NFA, and after doing that, we have to put the equations of all these states to the equation of the final state, and that will give us the required regular expression for the given NFA. So this will become clear when we solve it, and let's see how we can do this. So here we see that we have three states, Q1, Q2 and Q3, where Q1 is the starting state and Q3 is the final state. So first of all, let us write the equations for the states that I was talking about. So first of all, let's check for the final state, that is Q3. So how do we write the equation for this? In order to write the equation for any state, check what are the incoming transitions to that state. So here we see that this is the incoming transition to Q3. It is coming from Q2 with an input A. So since it is coming from Q2 with an input A, we'll write it like this. And check if there are any more incoming transition to Q3. There are none. So this is the only one. And this one, let me call it equation number 1. That is equation for Q3. Okay, now let's do the same thing for state Q2. In Q2, we see that Q2 has incoming transitions from Q1 and also from Q2 and also from Q3. So we have to write all of them. We have to do the union of all of them. So let's see how we can do that. From Q1 it is coming with an input A. From Q1 it is coming with an input A plus from Q2 it is coming with an input B. Q2 input B plus from Q3 it is coming with an input B. Q3 B. So this one I'll call it equation number 2, and this is the equation for state Q2. Now let's do the same thing for state Q1. So what are the incoming transitions? Here we have this transition coming to Q1. So this transition that comes from nowhere, that will be called epsilon, plus we have incoming transition from Q1 itself, Q1 with input A, Q1 with input A, plus from Q2 it's coming with input B, Q2 with input B. So there are no more incoming transitions. So this will be equation number 3, and this is for state Q1. So now we have written the equations for states Q1, Q2 and Q3. Now what we have to do is we have to simplify these states. So first let's take equation number 1, and that is state Q3. Q3 is equal to Q2A, and we can substitute the value of Q2 from this equation number 2. So Q2 can be written as Q1A plus Q2B plus Q3B, and this A can be written as it is. And now let me simplify it further by taking this A inside. So Q1AA plus Q2BA plus Q3BA. So let me call this equation number 4. Alright, so let's do the same thing for equation number 2, that is the state Q2. So Q2, how did we write it? Q1A plus Q2B plus Q3B. So this is the equation for state Q2. Now what we have to do, let us simplify this. And how do I do this? What will I do is, here we see that we have Q1, Q2 and Q3. So what I will do is that this Q3 over here, I will substitute it with the value of Q3 from equation number 1. So let me write here, putting value of Q3 from equation number 1. So what do I get? Q1A will remain the same, Q1A plus Q2B also will remain the same, and Q3 can be written as Q2A, that is from equation number 1, and B as it is. Now let us simplify it further. Q1A plus Q2B plus, I'll take this B inside, so this becomes Q2AB. Now if you see that we have this Q2 and Q2, two times there are Q2, so I can take out Q2 common from this. So equal to, so this is Q2 equal to Q1A plus, let me take out Q2 common from here. So if I take out Q2 common, I get B here plus AB. Okay, so now if you check this equation is of the form R equal to Q plus RP, where Q2 is R and Q1A is Q, and this Q2 is R as we said, and this B plus AB, this whole term is P. And then if you remember, if you remember the Arden's theorem that we have studied in the previous lecture, we saw that whenever you have an equation of the form R equal to Q plus RP, it can be written as R equal to QP star. This is by Arden's theorem. So if you have not studied Arden's theorem, you can refer it in the previous lectures. So this equation is of the form R equal to Q plus RP, so I can write it in the form R equal to QP star by following Arden's theorem. So let me write it. Here R is Q2 and QP star. What is Q? Q1A. Q1A and P star, and P is B plus AB. This whole term is P. B plus AB star. So this I will call it equation number 5. So we have solved Q2. We have simplified Q2. Now let us take our equation 3, which was Q1. Equation 3 was Q1. So if you see, it is this one, Q1 over here. So let us write it over here. Q1 equal to epsilon plus Q1A plus Q2B. Now I'll try to simplify this Q1. So here we have Q1 and Q2. So we have already found the value of Q2 in this equation number 5. So let me put the value of Q2 from equation number 5. So if I put, what do I get? Q1 equal to epsilon plus Q1A plus, so instead of Q2 I will substitute this whole value of Q2 that we have obtained. So that is Q1A and then B plus AB star. Okay, and then that was Q2, and this B is remaining. This B will be written as it is. Alright, now let me simplify this further. So from here we see that we have Q1 and Q1. So Q1 can be taken out as common. So we are getting like this. Now again, if you check, this equation is also of the form R equal to Q plus RP. Let's see how. This is Q1. So this Q1 is my R, and this epsilon here, this is Q, and this is R again, and this whole term over here, this is P. So again, by Arden's theorem, this can be written as R equal to QP star. So let me write this whole thing in this form. This is R, Q1, and now QP star. What is Q? Epsilon and then P star. So P, this whole term is P. So I'll write like this: A plus A B plus AB star B, and the whole of this star. Okay, this star. So now we have written this again in the form R equal to Q P star by using Arden's theorem. Now if you see this, this is epsilon into this whole term. Now from our identities that we have studied, we already studied that epsilon into any regular expression R is equal to R itself. So here if you treat this whole thing as R, epsilon into this will be this one itself. So I can write this Q1 as A plus, I'll put bracket here, A, then B plus AB star B star. So we have written this using this identity that we have studied. So here we have got the value of Q1, and let me call this equation number 6. Okay, now we have simplified the values of Q1, Q2 and Q3. Now the final step that we have to do is we have to take our final state and substitute all these values in the equation for the final state. And what is my final state? My final state was Q3, if you remember. And what is the equation for Q3? Q3 is equal to the first equation that we had for Q3, this one, Q2A. So let me take this equation, Q3 equal to Q2A. Okay, now this value of Q2, let me substitute it with the value of Q2 that we got from equation number 5. So this is the value of Q2 that we have finally obtained. Okay, that is equation number 5. This one I got it by substituting the value of Q2 from equation number 5. So let me just write it here. Okay, so now let's substitute the value of Q1, this Q1 from this equation number 6. So Q1 can be written as A plus A B plus AB star B the whole star, that is from this. Okay, so we have substituted the value of Q1. Now the remaining terms we can write it as they are A, then B plus AB star A. And how did we get this? This is by putting value of Q1 from equation number 6. So this Q1 was replaced by the value of Q1 from equation number 6, and the rest of the things were written as they are. So this is my final state Q3, and we see that now they are all expressed in terms of the inputs A and B, and this is the required regular expression for the given NFA. So let us just recap the steps once more how we did this. So when we are given NFA like this, what we do is we first write the equations for each of the states like this, and after writing the equations we simplify those equations using Arden's theorem and other simplification techniques that we have used. And finally, after simplifying all the equations for each of the states, we take the final state, and into the final state we substitute the values of each of the equations of the other states, and finally we obtain an expression which is expressed completely in terms of the input symbols, and that is the required regular expression for the given NFA. So that is how you convert a given NFA to its required regular expression. I hope it was clear to you. Thank you for watching, and see you in the next one.